everybody. So I'm making a series of videos here that is going to be all about describing a distribution. So in order to describe a distribution, what you're going to need to do is draw some sort of picture. So you need some sort of graphical display of the data, whether that is a stem and leaf plot, a histogram, a dot plot, a box and a whisker plot, whatever. Okay, and then you're going to go and you're going to write a few short sentences describing that distribution, basically describing what you see. So that can be pretty tough depending on what you get because there's so many possibilities of what you can actually see with a data set. So this video series I'm about to make is going to go through all the pieces that you need to talk about. So what we use is SOCS, S-O-C-S, where we're going to describe shape, outliers, center, and spread. So in this video, I'm going to talk about shape, which is the one that I feel like can get the most complicated as we go through. So what I'm going to do is I'm going to go through the different types of graphs you can have and what those shapes look like for each. So we'll start with box or stem and leaf plots, then histograms, then go to dot plots, and then go to box and whisker plots. So stem and leaf plots, they can be a little bit tough to see their shape. The easiest way I feel like you can see it, if I'm starting with this first one, is turn it sideways. Okay, turn it sideways. And what you want to imagine is if I was able to draw a line to trace kind of what's going on here, that'll help you see the shape. So when I look at this first one, it kind of has one hump right in the middle, and it's pretty balanced on both sides. When you have that balance on both sides, we're going to call that symmetric. Okay, we're going to call that symmetric. But here's the deal. When you look at it, it really isn't perfectly symmetric, and most data sets out there are not going to be perfectly symmetric. So what we're going to do is we're going to call that roughly symmetric. Nothing is ever perfectly symmetric, so we get away with it by saying roughly symmetric. The other thing that was here, that's probably the more important thing to say, but the other thing that we could see in this shape is, yes, there was one hump, so we're going to call it unimodal. Unimodal, which means there's one kind of very pronounced hump there. My second one, what we see here is, we see all of our data, great, grand, wonderful. Again, with stem and leaf plots, it helps to either turn your head sideways or just turn the entire paper sideways. If I saw this, I got a kind of big hump here, and then it flattens out a little bit on the left side. There's a few things I would want to talk about with this one. So first thing I would want to talk about is, yes, we have a lot of data on the right side, and it looks like it starts flattening out towards the left a little bit. So what we call that is skewed left, okay? Because the flattening out piece, again, I'm going to draw on this. I don't recommend it all the time. It flattens out on the left side. That's a skewed left. Now, if you're not really good with, well, which direction is it, left or right? Because those could be easy to mix up. Talk about where is this skew happening? Where's the flattening happening? Well, it's on the left side or in the lower numbers. So you could say skewed to the lower numbers. Okay, that's another thing you can say. So if you don't like left or right, you could say skewed to the lower numbers. One other piece I would talk about with this specific graph is, and the shape is, there is a gap here. You'll notice that we had 13, nothing in the 20s for whatever this data set is, and then we have a 35. So we have a gap in the 20s. That's pretty important to share, so I would say there is a gap in the 20s. Now, I don't have, these are very, very loose examples just to talk shape. You would want to add context there. If we're talking students, 20 students, whatever it is, okay? So that's talking shape with stem and leaf plots. Let's talk histograms. Histograms is a little bit easier to kind of see shape because you don't have to do any turning sideways. So this first one, you see the data kind of stacked up here on the left side and then really flattens out on the right. So again, I would say the shape of this graph is skewed right, or you could say skewed, and these are the larger numbers, to the larger numbers is another way of saying that. Skewed to the larger numbers. My second graph here, it's a little bit tough to kind of see shape there. We have a stack here, and then we have this little digit out here. If I'm not really sure, and you say you're lacking confidence on it, then don't talk about, oh, I don't know, is it roughly symmetric? Is it skewed? talk about what you know for sure. What I know for sure is there is a gap at 4. So you'll notice I had data at 1, I had data at 2, I had data at 3. All of a sudden, nothing is happening at 4, and then I have a data point at 5. So I'd say there's a gap at 4. If you're not really sure, well, I don't know, is it roughly symmetric? Is it lightly skewed? Then back off on it and say, you know what, I'm not really sure. It's not really clear to me. Next one, dot plots. Still something we can encounter there. So just a basic dot plot here. If I look at this one, I have 3 dots in the first, 3 dots in the second, 4, 2, 3. So almost all of them have 3. So it's the same amount of data throughout, but it's not perfect. So you could call this uniform, but it's not perfectly uniform. So again, cover yourselves. Roughly uniform or lightly uniform, something like that. It's close, but it's not exactly perfectly uniform, so be careful there. And then we have our box and whisker plots, which honestly are the ones that I feel like pop up the most often, and people have a really, really tough time with them, so we'll spend some time on that. So these are just really quick, drawn together box and whisker plots. Yeah, they're missing, you know, titles and labels of, well, what do these numbers represent? It's just basic ideas. So you'll notice this first box and whisker plot, we have very, very short whiskers, but they're about the same on both sides. In my box, the width there, with the median in the center, the box is kind of split evenly as well. So guess what? This one's roughly symmetric. Roughly symmetric, okay? Because you have that balance that if you look at the median, which is supposed to be the center, you look on the left side and it's pretty similar to the right side. Same thing on this one. So I kind of switched things up. I made a smaller box but bigger whiskers. If you look at the center, which is the median, the left side has a long whisker in a short box. You look at the right side, a long whisker in a short box. So this also would be roughly symmetric. So both of these roughly symmetric. To the top right here, more stem and leaf plots. We look at where is the center, the median. So the median, we have a short whisker, short box on the right, but we have a long box and a short whisker. So this would be skewed because it stretches out really on the right side. So skewed right. One right below it, there's my median, short box, short whisker, short box, long whisker. So things really stretch out on the right side. So that is also skewed right. And then my final 2 examples, you'll see where I'm going with this. Check out where that center is, that median. Short box, short whisker to the right, but really stretched out box, short whisker. And the second one, short box, short whisker, short box, long stretched out whisker. So either the box stretches out a lot to the left or the whisker stretching out a lot to the left. So this is skewed left. Okay, so these are just some basic drawings. Yes, there's more variations out there. It kind of depends on your data set, and I can't come up with every single example out there. Just stick to what you know. If it's very, very obvious to you that it's skewed one way or the other, be confident in saying that. If it's looking roughly symmetric to you, be confident in saying that. If it's a very obvious gap, be confident in saying that. Whenever you get to those points where you're like, man, I'm not really sure if it is or isn't, then leave it alone. Only talk about what you're confident in. So if you're like, well, I'm not really sure about that gap, but I am sure about the skewness, then just say the skewness, right? So only say what you're confident in. So this is the first part of describing a distribution, that is describing shape. Be sure to check out my other videos that are going to talk about outliners, center, and spread.